Hello everybody, welcome back to Reading for Vocabulary. We're on our last lesson of the book. I hope you enjoyed studying with me, but we have one more lesson to go, so we have something more interesting to go over before we finish with the book. And of course, we're still talking about the topic of cycles, right? Things that go around that continue and continue. They don't really have a beginning or end, they just continue to go. This lesson, lesson 15, we're talking about as the earth moves. So now we're talking about the cycle of the earth's motion. As you know, you should know, the earth moves around the sun. That's a cycle. But we'll talk about some other cycles too that you may not know about concerning the earth's motion. So that's what we're going to read about. We're going to focus on Earth's motion and weather. So we're not just talking about the motion of the earth, but we're also talking about how does that affect the weather? How does that change the weather on Earth, right? When the earth is moving through space, what effect? How does that change the weather on Earth? So it'll be an interesting lesson about that. But of course, as usual, let's study some vocabulary so that we can understand the reading passage more quickly when we get to that. Okay, the first word on our word list is defined as to understand well. And I hope you've understood my lessons well. What is another word to understand well? It's to comprehend. It's a big word, right? Comprehend. Only 3 sounds, so not so bad. Comprehend. Comprehend means that you understand well. So like I said, I hope that you comprehend my lessons with you well. I hope that you can comprehend, and I hope that I explain things well enough. Okay, good. So number 2, to make bare. When you make something bare, like when I get a haircut, right? I expose my head. If I get a really short haircut so you can see my skin, then I've exposed my head, right? To expose something, to make bare. If I roll up my sleeves, you can see the skin on my arms. I have exposed my arms, right? I'm not going to do it. That takes too long. But you get the idea, right? You take off a hat, you've exposed your head to the sky outside, okay? So to expose, to make bare. Next one. Half of a sphere. Now a sphere, what is a sphere? A sphere is a round shape, but not just 2-dimension, 3-dimensional. That's a sphere. So if we look at the earth, right? The earth is a 3-dimensional circle, right? It's a sphere. A circle is only 2 dimensions, right? A circle is just 2 dimensions, but a sphere is 3 dimensions. We can see the shape in 3D. Okay, so half of a sphere. But now we're talking about half of a sphere. So if we talk about half of the world, usually we talk about like the northern half or the southern half. And when we do that, we use a special word, and that word is hemisphere. Hemi. Now, think of this word, it's one word, but think of it in 2 sections. First we have hemi, and then we have sphere. Of course, you know a lot of English words are shorter words or smaller words that are joined together. In this case, hemi is a Greek word. It has its origins in the Greek language, as many words do have origins in Greek or Latin, right? In this case, hemi is a Greek prefix. Hemi means half. Hemi is half. So if we say hemi, half a sphere, we're talking about half of a sphere. And so we say the Northern Hemisphere or the Southern Hemisphere. Sometimes people will also say the Western Hemisphere and the Eastern Hemisphere, saying that the West is, for example, Europe and America, and the East is Asia, right? Sometimes people will say that. But usually, you know, it's hard to say, you know, where does it stop and end? But it's easy to know north and south because there's the equator, right? There's the equator right here that is a good dividing line for north and south. So we can easily say Northern Hemisphere and Southern Hemisphere. Okay, next word, number 4. Maybe you've seen this picture before. It's not to scale, right? If it was to scale, it would be too big. We couldn't show it here. But this shows the sun and all the planets around the sun. And we see that the planets have these lines, these circles going around. And we see to move around an object in space, right? This is space out here. Nothing's really out there. Also, we see a comet over here that also moves around an object in space. All of these objects are moving around the sun. We say they are orbiting around the sun. So Mercury, Venus, Earth, Mars, they are all orbiting around the sun. They are moving around the sun. The comet is moving around the sun. Now, on a planet like Jupiter, which has many little moons, those moons are orbiting around Jupiter. Our moon, the moon that we see at night, orbits around Earth. Okay, so there are many different orbits that we can see in the night sky. It just means an object, a big object is moving, well, not even a big object, could be a small object. Like when astronauts go into space, they go around the Earth, they are orbiting the Earth to move around another object in a circle or some type of circle. Okay, number 5, the very top or bottom of the Earth. So here we're looking at Antarctica. Antarctica. And on the other side, of course, there's no land, right? Antarctica is a land mass. There's no land on the other side. But what we're talking about the very top or bottom of the Earth. Of course, we're talking about the poles. And here we see the South Pole. Antarctica is at the South Pole. There's no land at the North Pole, but there is ice, right? And animals do live up there, like, for example, polar bears live on the North Pole. Santa Claus has his house at the North Pole, right? Okay, so these are the poles, South Pole or North Pole. Number 6, to be on top of. So to be on top of, especially to be all over the top of, not just sitting on the top here, but all over the top means to cover. So this blanket is all over the top of the car and it hides the car. Actually, we can't see the car. We know it's a car because we can see part of it right here. But if we can't see it, we see that this blanket or this sheet covers the car. Okay, so cover doesn't just mean to be on top of something. Like, for example, if there's a dog here, right? I'm not a very good artist, but okay. Anyway, that's my doggy. If the dog is sitting up there, the dog is not covering the car. To cover means to cover all the entire surface of something. To cover a large surface of something. That's to cover. 7. Not circular, shaped like an egg. So this looks like a mirror, right? Okay, but it's not a circular. A circle is more like this. Now, can I draw a circle? I'm okay. That's not a very good circle. Again, I'm not a very good artist. But if you can draw a perfect circle very quickly, perfect circle, that's a circle. But this is not a circle. This looks like an egg. So what do we call it? We call it elliptical. Elliptical. Now, an easier word, of course, is also oval, an oval shape. This would be an oval shape, but more scientific word is elliptical. Elliptical. Elliptical shape is like an oval. It's not a perfect circle. Okay, 8. A particular length of time. So a particular length of time, beginning and ending, and we call that, that's a certain period of time. I just gave you the word period. A period of time is what we call a particular length. So an hour is a period of time. A minute is another period of time. A second is a period of time. So there's many different periods of time. It's just a particular length of time. We give it a name. Okay, number 9. Now this girl has a decision to make, right? She can go right or she can go left. So she's thinking of something. What is the verb that means to think of something? Especially to think about it deeply is to consider. She is considering, okay, what's the fastest way to get to the store? Should I go right or should I go left? Okay, so she's thinking about it. Okay, she's considering her choices, especially when we have a choice to make. We consider the good points and the bad points about each choice, and then we make our decision. So we consider. Number 10. something that influences or has a part in. So something that influences or has a part in, we call that a factor. Now this is more of a maybe a scientific word, right? A factor is like, for example, I just said we think about the good points or bad points. All the good points, that's a factor. All the negative or bad points, those are also factors. We call those pros and cons, right? Pros are good points and cons are bad points. These are all the factors that we use. We think of all these things when we consider something. So they're all the things that influence our choice or has a part in our choice or the result of something. Those are factors. Okay, next one. Uh-oh, somebody's in trouble, right? I think the cat knocked over the potted plant and the dog is looking at the cat saying, you're in trouble, you know, when master comes home, okay? To be the cause of something is to be responsible for. Responsible. So, responsible. Responsible. Who is responsible for this mess? Who is responsible for breaking the pot? I think it's the cat. What do you think? Who's responsible? But sometimes, you know, if something happens, there's an accident that happens, people will ask, who's responsible? They'll also ask another word, they'll use another word, fault, right? Fault. And when you use fault, you can say, it's my fault. If you say it's my fault, that means I am responsible. I am responsible. I am responsible. It's my fault. Whose fault is it? Who is responsible? It means the same thing. Okay. 12. Oh, Kyepchio. Maybe Kyepchio, maybe a little ugly, but it's very cute, right? These two dogs in a very small way. Now, what are we talking about? We're talking about slightly. So these two dogs are slightly similar. I'm not really sure what we're doing with the picture here, but slightly, in a very small way. Maybe they're licking their lips slightly, all right, just a little bit, in a very small way. Slightly. If you do something, but it's not in a big way, it's in a small way, you can say slightly. Give you another example. It rains, right? Sometimes it rains heavily, really coming down. That's not slightly, it's not slightly raining, it's heavily raining. But if it's raining and just the little tiny drops are coming down, you could almost go outside without an umbrella. You won't get too wet. It's just raining slightly. Just jokum, right? Jokum piwao, right? Just a little bit of rain is falling from the sky. It's slightly raining. Okay, next one. Here looks like a calendar, Monday, Tuesday, Wednesday. Not long lasting. If something doesn't last a long time, it only lasts 1, 2, or 3 days, it doesn't last very long, depending on what it is, right? If we're sick for 3 days, we think it's a long time, but really it's just short term, right? It's done in 3 days. It's over in a day or 3 days, right? Short term, it doesn't last very long. What's the opposite of short term? Well, of course, we would say long term, pandero, right? Long term is the opposite, pandero, of short term. So you can talk about something that's short term, and you can talk about something that's long term. Okay, those are opposites. 14. Now, somebody made a mistake here, right? 1 plus 1 equals 3? That's crazy. The word is defined as something that is smart and logical. We would say it's sensible, sense. It makes sense. Now, usually when we use sense in a sentence, we don't say its sense. Don't say its sense. Say it makes sense. You have to remember, use this word here. It makes sense. Don't just say its sense. No, it makes sense. Now, this doesn't make sense. This doesn't. It doesn't make and then we use S because doesn't. It doesn't make sense. 1 plus 1 equals 3. That doesn't make sense. Okay, it's not smart, it's not logical. Okay, so when we use the word sense, we use it to describe something that's smart and logical. That makes sense. That's logical. When something is not logical, we say it doesn't make sense. Okay? Okay, next one. For the entire year, and of course, this looks like, I'm not sure, but I think it's Mount Everest in the Himalayas. And you think about Mount Everest. Whenever you think about Mount Everest, you think of snow. And it doesn't matter what time of year it is. It could even be the summertime. There's still snow in the mountains, on this mountain, because the mountain's so high. So for the entire year, we say year-round. There is snow year-round on Mount Everest. That means all year long there is snow on Mount Everest. It's year-long. Okay, last one. According to science, this guy is very smart, right? He's doing some kind of engineering diagram. Okay, technically, if he's doing something and he's getting into, according very specifically how it's used. Technically, you could say it's according to a scientific method, according to science. It's done in a very logical or in a very detailed way. And you're breaking down all the different parts. How is each part going to work? Well, that's a technical drawing. So they've done it very technically. Now, sometimes people will use this word technically, right, adverb, to describe something exact. For example, a lot of things we just say generally, and they may not be true, right? Exactly. They might not be true in all cases. So in that case, we say, well, technically, that's not true. Technically, da-da-da-da-da. We say, okay, well, that's not the common case. Generally, it's this way. But technically, it might be a little different. Okay? So we'll see that later on in the reading passage. Okay, let's go over these words here. Let's do the exercises. Choose the word that best completes a sentence. Can you beep this math problem? So when you're looking at a math problem, sometimes math problems are difficult to understand. So we might ask our friend, can you what this math problem? Usually maybe we're looking for a word like solve or understand, right? Well, what word means that? A, behave, B, comprehend, C, orbit, and D, cover. Well, of course, we're looking for comprehend. Can you comprehend this math problem? Because comprehend means, do you understand this math problem? If you understand it, then you can solve the math problem. First, though, you need to comprehend it. You need to understand it. Once you understand it, then you can solve it, right? So, not can you behave, not can you orbit this math problem. That's weird. Can you cover this math problem? Oh, I'm afraid. Cover it, hide it, right? That's strange too. What we want is, can you comprehend this math problem? Do you understand it? Okay, next one is a command. Beep your eyes. You shouldn't see this. So if your friend says, oh, don't look, right? You want to do this to your eyes. What am I doing, right? So I cannot see something. Am I orbiting my eyes? That would be really weird, right? My eyes turn around. That's strange. Now, I'm not orbiting my eyes. Am I comprehending my eyes? Well, I understand my eyes, but I can still see. That's weird, right? We don't say that. Make your eyes? How do you make your eyes? That doesn't make sense. Cover. Cover your eyes, right? So you have a surprise. I want to surprise you. Cover your eyes. Open a surprise, right? So first, cover your eyes. That's the answer. Cover your eyes. You shouldn't see this. So you don't want somebody to see something. Cover your eyes. Okay, next one. Number 5. I have a short beep of time for lunch. So you have a certain length of time for lunch. It's a short length of time. What do we say? I have a short orbit of time. I have a short pole of time. I have a short period of time. Or I have a short cover of time. Which one sounds good? Probably you chose period. Whoa, that's too fast. Okay, but anyway, I have a short period of time. I have a short period of time for lunch, so maybe only 30 minutes. 30-minute period for lunch. Not 1 hour, just 30 minutes. So it's a short period of time. Now this one jumped up too quickly, but that's okay. The North Pole is in the Arctic. Remember we talked about pole, right? We have a North Pole and a South Pole. Those are the top and the bottom of the Earth. And the North Pole is in the Arctic. Not the North Orbit, not the North Cover, not the North Period, that's weird, but the North Pole. The North Pole is in the Arctic. Where is the South Pole? The South Pole is in the Antarctic. Arctic, yes, if we can spell it right. Oh, yes, we did. Okay, Arctic. Okay, you can see because Arctic, you just use Arctic here, but Antarctic means the opposite, Antarctic. Okay, so Arctic, Antarctic. Okay, well that wraps it up for the vocabulary section. Next, we're going to use those words in the reading passage, so stay tuned, don't go away. Hello everybody, welcome back to the reading section. In the reading section, we're going to figure out, or we're not going to figure out, we're going to read about, right? We're going to read about how the Earth's motion affects the weather on Earth. Kind of interesting. Okay, so let's begin. Weather changes from day to day and month to month. But did you know it also changes from year to year, and not just every few years, but over millions of years? Wow, okay? So we know the weather changes from day to day. One day it's sunny, the next day it might be rainy. So it changes from day to day. And we know it changes from month to month, right? It will probably snow in February. Maybe it won't snow in March. It's probably not going to snow in May, right? So we know that the weather changes from month to month. And of course, did you know that it also changes from year to year? Did you know that, right? You're kind of young now, so you don't have a lot of experience. But as you get older, you'll start to notice, it didn't rain that much this summer. Or, oh, this winter isn't as cold as it was last year. So the weather also changes from year to year, right? One year might be different than another year, right? I know I'm looking at the news from America this year, and they're complaining it's so cold in America this year. It's really cold. But I noticed that in Korea, the winter isn't that bad. It's a lot better than it was last year, right? So weather changes not only year to year, but also for region to region. You know, it's not always the same. But anyway, it changes from year to year. And not just every few years, but over millions of years. Now, people really don't realize this because, we only live, average life is maybe around 80 years, right? So people don't really remember more than 80 years ago, right? The very old people, right? So nobody remembers what the weather was like a million years ago, right? But scientists can figure out, they have ways to determine what the weather was like millions of years ago, and they found that there's a cycle, that the weather changes from millions of years. Sometimes it's really cold, sometimes it's warmer, and it changes over millions of years. Short-term changes make sense because we see and feel them. Long-term changes aren't so easy to comprehend. So that's what I'm talking about, right? Short-term changes. We can see the change from day to day. That's very short-term. Month to month, that's short-term. When we talk about the Earth's history, right? Year to year is also short-term. Our lives, like I said, typically maybe we live 80 years if we're lucky, right? Even if we live to 80 years, that's still short-term because we're talking about the history of the Earth, which is very, very, very old. It's difficult to comprehend. It's not so easy to comprehend. Long-term changes over millions of years, they're hard for us to understand because people only really live, maybe to about 80 years. If people are really lucky, 90 years. Sometimes you hear about people living over 100 years. But anyway, people don't live that long. We can't comprehend, we can't understand those types of changes. It's hard to. We can, but it's not easy. The seasons are well understood. Everybody knows about the seasons. As Earth orbits around the sun, different parts are exposed to different amounts of sunlight. For 6 months, the Northern Hemisphere is directly facing the sun, and so the weather is warmer there. You guys know about the seasons. You studied that in school, right? Everybody knows, spring, summer, fall, winter, and the weather changes because the Earth is moving like this. It's not just moving around the sun, the Earth is also tilting, right? Now, we well understand that because we learned about this in school. As Earth orbits around the sun, different parts are exposed to different amounts of sunlight. So as the Earth is moving, right, it's also moving this way. And what they're saying is, for 6 months, the Northern Hemisphere, so the Earth isn't going like this, it is going like this, but over a very, maybe long term for us, 6 months. 6 months it's tilted like this, so the northern part, the Northern Hemisphere, is directly facing the sun, and then it slowly turns, so then the southern part is directly facing the sun. So the Earth is doing this as it moves around, but it's very slow, right? It's like this, da 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 da, and it's slowly turning, and then it'll go like this when it's over here, right? So the Earth is moving like this, but over a year, right? Over the time of a year. And that's why the weather is warm in the Northern Hemisphere. Korea, of course, is in the Northern Hemisphere, and we feel it's warm in the summertime. It's warmer in the Northern Hemisphere in the summer. For the next 6 months, the Southern Hemisphere, right, it turns back this way, the Southern Hemisphere is facing the sun, so it is warmer there and colder in the north. The cycle starts again when the Earth completes its 12-month orbit around the sun. And you can kind of see this, right? The Earth is spinning like this, but it's also going around the sun. And also, you can't see in this picture, but it's also tilting like this, right? So for the next 6 months, the Southern Hemisphere is directly facing the sun because the Earth kind of tilts. So the Southern Hemisphere, as it rotates, that's the one facing the sun. So it's warmer there. It is warmer in the south there and colder in the north. That's when we have winter, right? We have winter when the southern part of the Earth is facing the sun. And of course, the cycle. We talked about cycles before in a previous lesson. They go around and around, right? So it turns like this, and then it turns back. It's constantly moving back and forth. That's a cycle, right? So it takes 12 months for this cycle to start again. And that's why we have 6 months warmer weather, 6 months colder weather. So that's, part of spring, summer, and part of fall is warm. The end of fall, winter, and the beginning of spring is cold. Okay? And that's what's going on. Okay, let's continue. Then there are ice ages. An ice age is a period of time when the poles are covered by ice year-round. There have been 5 ice ages on Earth, each lasting for millions of years. Most people think the last ice age ended thousands of years ago, but technically we are still in it. Okay? Now, of course, there are ice ages, right? There's Ice Age 1, Ice Age 2. Remember the funny characters running around, right? Okay, that's a movie. I'm just kidding. Of course, you probably saw the movies, right? And it's kind of a funny movie. They're talking about when the Earth was covered with ice, right? The ice is moving and the animals are running away from the ice. That's kind of the idea, but of course, it's just a cartoon. It's not very scientific. It's fun, it's entertaining, but it's not really accurate. Okay, but anyway, we know about ice ages, right? Especially from the movies, okay? So an ice age is a period of time, usually millions of years. That's how long of a time when the poles, and of course we're talking about poles, we're talking about North Pole and South Pole, when the poles are covered by ice all year round. So that's interesting because we normally think the North Pole is covered with ice. We normally think Antarctica is covered with ice, but that's not the normal situation. that only happens during an ice age, right? And there's only been 5 ice ages since the Earth came into existence, right? So think about that. A lot of the time, there was no ice covering the North and South poles. Okay? So that's not an unusual thing. That's a natural thing, actually. Before humans were even on Earth, there were long periods of time when the North Pole and the South Pole were not covered in ice. Okay, so that's something to remember. That's something we don't normally think about because, of course, as human beings, we don't normally think beyond our own lifetimes. Okay, there have been 5 ice ages on Earth. Each ice age lasts for millions of years. Okay, we're talking about huge amounts of time here. Very difficult to understand or comprehend. So most people think, that's like common knowledge. Well, most people might think this way. And a lot of times, the way that most people think isn't always true, right? So we got that word over here technically. Let's get to that. Most people think the last ice age ended thousands of years ago. So thousands of years ago, when human beings, before human beings wrote history, before human beings really had a lot of knowledge about technical progress or a lot of technology. They were still living in caves and hunting animals with spears, right? When humans were very primitive. Ice covered most of the Earth, right? There was ice that covered a lot of Europe and a lot of North America, right? And human beings had a very difficult time. They couldn't really live very well in those areas. It was much colder in that time, right? So then we know the ice went away. So most people think, okay, that was the end of the ice age. But technically, actually, scientifically speaking, we are still in it. In what? The last ice age. We are still in the last ice age. Why? Because the poles are still covered by ice year-round. There's still ice at the North Pole year-round. There's still ice on Antarctica in the South Pole year-round. So technically, scientifically speaking, we are still in an ice age, which is interesting. Next one. Within an ice age, there are warmer and colder periods. Right now, the Earth is in a warmer period that has lasted for about 11,000 years. Interesting. So technically, we are still in an ice age, but during the ice age, right? The ice age lasts millions of years, so it's not always the same during those millions of years. Sometimes it'll get warmer, sometimes it'll be colder. It's still an ice age, but it's just a warmer ice age or a colder ice age. Within an ice age, there are warmer and colder periods. Right now, chigameo, right now. And of course, when we say right now, we think, this second. But when we're talking about the history of the Earth, right now, we could mean thousands of years, right? Right now, the Earth is in a warmer period that has lasted for about 11,000 years. Now, it's even hard for us to think about 11,000 years. Think about 2,000 years ago, the Romans and the Greek civilizations. It's hard for us to think about that. But now we're going to go back 9,000 years before that. That's no mo himdro to comprehend, isn't it? It's very difficult. But this warm period, we're still in an ice age, but it's a warm period that has lasted for 11,000 years. Very interesting. Okay, one reason for these cycles of warm and cold is the Earth's elliptical orbit around the sun. Because it isn't a perfect circle, it actually changes slightly over thousands of years. So and of course we have a nice picture of the ice age, right? These big sheets of ice coming, right? And then the trees down below. Anyway, let's talk about this. Why is there warmer and colder periods during the ice age? Why? Why is that? Because the Earth, if this is the sun here and this is the Earth out here, the Earth doesn't travel in a perfect circle. It kind of has an elliptical orbit. I'm not very good. But sometimes it'll be closer to the sun, but over here it's farther from the sun. Well, of course, you know the sun gives us heat. So if we're farther from the sun, right? If we have an elliptical orbit, like an oval, right? It's not a perfect circle, right? It changes slightly. It may take a long time, you know, for the Earth to, well, it takes a year, of course, to go around, but it's not always going around in a perfect circle. You know, it actually changes slightly over thousands of years. So the Earth's orbit doesn't always go around in a perfect circle. Sometimes it goes out a little bit further from the sun, and that takes thousands of years to happen, to change. So sometimes the Earth is actually farther away from the sun, and that's why it's cooler. And then when it gets closer to the sun, it gets warmer. And that's what they're talking about here. From studying changes in the Earth's orbit, scientists think the Earth should be heading into a colder period right now. Again, right now means over the thousands of years. But it is actually getting warmer. Many scientists think humans are responsible. Okay, so scientists will study changes in the Earth's orbit. They'll look at how the Earth's orbit changes. Not a perfect circle, but you know, sometimes further, sometimes closer. So scientists think the Earth should be, they think the Earth should be going into a colder period right now. So the ice age is coming, right? But it's actually getting warmer. So scientists think, you know, the Earth should be getting colder, but actually it's getting warmer. So many scientists think humans are responsible, okay? It's hard to tell, though, because there are so many other factors to consider. Maybe humankind hasn't been on Earth for long enough to really understand these ancient cycles. Okay, so the previous one saying maybe humans are responsible. How? Because you've heard of course, you've heard of the greenhouse effect. You've heard of global warming. Many scientists think humans are responsible for that. But it's hard to tell. It's very difficult to say that that's the reason. Why? Because there are so many other factors, right? It's not just human activity. It's also volcanoes that explode. It's also the Earth's orbit, right? It's also the fact that the Earth is moving through space. Sometimes it moves through an area where there's a lot of dust, and that might block the sunlight reaching the Earth. So there's so many different factors, it's very difficult to figure out. And another problem is maybe humankind hasn't been on Earth for long enough to really understand these ancient cycles. Like I said before, you know, humans have only been on Earth for 200,000 years, but really we've only been studying the weather for maybe the last 2,000 years, or maybe a little bit more than that. The ancient astronomers would look at the sky and they would record the weather, but we don't have a lot of those records, right? They weren't very good at writing things down, and of course a lot of those things were lost over time. Nowadays, though, of course, we study the weather very much. You know, you turn on the television, you can see all sorts of maps and, you know, all sorts of charts and many people talking about the weather, but that's only been for a very, very short time when you think about the entire life of the Earth. So the other thing is maybe we haven't been around long enough. Maybe we need to study this more. Maybe it will take hundreds more years to really understand what's going on. Maybe not just hundreds of years, because again, hundreds of years, that's very fast when we're talking about these ancient cycles. Okay? Okay, so let's talk about this story. What is this story about? This story is about what? A, why the Earth moves. B, short-term cycles. C, the cycle of the seasons. And D, the different weather cycles on Earth. Did we talk about why the Earth moves? Did this passage explain the reasons for the Earth moving? No, it didn't. It's just assumed that the Earth is moving. And that's another subject, right? That's another reading passage. Okay, but we didn't talk about why the Earth moves. Did we talk about short-term cycles? No, we're talking about millions of years and even cycles that last for 11,000 years. Those are not short-term cycles. We're talking about very long-term cycles. Are we talking about the cycle of the seasons, right? Summer, spring, summer, fall, winter? We're talking about that cycle, that 12-month cycle? No. We're talking about the different weather cycles on Earth. So this story is about the different weather cycles on Earth. And we did talk about the cycle of seasons briefly, but we also talked about ice ages, right? That's another cycle of weather changes on Earth. So it's more broad, the different weather cycles on Earth. Not just the seasons, not just day to day, but over thousands and millions of years. Okay, let's move on to number 2. It is summer in the Southern Hemisphere. So we talked about that, I kind of try to show you with my hand, the Earth tilting or moving this way. Now think about it. In what time summer in the Southern Hemisphere? When is that? A, when the Southern Hemisphere is, we're talking about the Southern Hemisphere, when it is facing the sun, when the Southern Hemisphere is facing the sun. B, when the Northern Hemisphere is exposed to sunlight. So the Northern Hemisphere, it would be turned like this, and the sun is here, is facing the sun. For 365 days a year, or D, every 3 months. What's true? Of course, you're going to choose A. It is summer in the Southern Hemisphere when it is facing the sun. Of course, it means the Southern Hemisphere. When the Southern Hemisphere is facing the sun, of course it's summer because then it's hotter. The sun is directly shining on the Southern Hemisphere. The Southern Hemisphere is exposed to the sunlight. Not when the Northern Hemisphere is exposed to sunlight. In that case, it's winter in the Southern Hemisphere. So that's not true. For 365 days, how many days are there in a year? 364 days, right? 365 days in a year. Well, depending on whether it's a leap year or not. But anyway, that would mean that there's no change, right? Or that the Southern Hemisphere is always facing the sun. But that's not true. We know that. It's a 6-month cycle. D, every 3 months. No, we know that that's not true. We know that it's 6 months for summer, 6 months for winter. Well, 6 months warmer. Fall and spring are included in the warmer period. Half of spring and half of fall. So it's not every 3 months, it's every 6 months. But anyway, A is the right answer. It is summer in the Southern Hemisphere when the Southern Hemisphere, is facing the sun. Okay, so the next one, number 3, the Earth. That's easy, right? We have to find the sentence that is true about the Earth according to the reading passage. So let's go over the wrong ones first, okay? Which ones are wrong? The Earth, A, is in its first ice age. Is that true? That's not true. Not in its first ice age. It's in its 5th ice age. In its 5th ice age. So that's wrong, okay? B, the Earth has been in the last ice age for about 11,000 years. Did the reading passage say that? The reading passage mentioned 11,000 years, but what did it say? It said, many people think the last ice age ended 11,000 years ago. That means that the last ice age started a long time before 11,000 years ago. And not that we've been in the last ice age for about 11,000 years. No, that's not what that means. It means that people think the last ice age ended 11,000 years ago, but that means the ice age started a long time before that. So that's not right. Let's skip C for right now. The Earth is orbiting around the sun in a perfect circle. A perfect circle? No. As we know, as we saw in the reading passage, the Earth is not moving in a perfect circle. It's moving in an elliptical orbit, which is not a perfect circle. It's like an oval. So that is not true. That leaves us with C. The Earth is in a warmer period. Yeah, the reading passage said that. The Earth is in a warmer period. Technically, we are still in an ice age. But for 11,000 years, starting 11,000 years ago, the Earth has been getting warmer inside that ice age. We're still in an ice age, but it's just a little bit warmer period of the ice age. Okay, let's move on to the last one. Okay, number 4, that's our last question. Scientists think. What do scientists think according to the passage, right? Which one is true? Let's go over them. Scientists think A, that the Earth's orbit has become elliptical in the past 11,000 years. No, scientists didn't say that. They didn't talk about that. The Earth's orbit has always been elliptical, so that's not right. Scientists think B, the current ice age is almost over. No, scientists think that we're just in a warm phase of the ice age. They think that it's supposed to be getting colder, that the ice age is continuing. So B is not the right answer. Scientists think C, the Earth should be getting warmer. No, I just said in number B that scientists think the Earth should be getting colder, right? We're in a warm period that's over, that's ending. Scientists think the Earth should be getting colder, not warmer. So that leaves us with D. Scientists think humans might be the reason why the Earth is getting warmer. Yes, the passage said that, but they're not sure. That's why they said might be. There's a lot of factors that affect the Earth's climate, right? And we think that the Earth is, many scientists believe that there is a global warming period going on, and they think humans might be. They can't say 100% for sure. They think humans might be the reason why the Earth is getting warmer, and that's what the passage said. So, scientists think humans might be the reason why the Earth is getting warmer. That's the answer. Okay, well, this is an interesting lesson, an interesting reading passage. You know, in not just this lesson, but in other lessons also, we noticed that it's very important to think beyond our own lifetimes, especially when we're talking about the Earth. Of course, the Earth is very important to us, and we have to think and we have to consider a lot of issues that affect the Earth because, you know, we're getting more and more populated. We're affecting the Earth more and more because of how many human beings there are on the Earth. But we also have to remember, we've only been on the Earth for a short time, and sometimes it's hard for us to think beyond our own lifetimes and even beyond the time that human beings have been on Earth. And it's a very interesting and fascinating, maybe a little bit scary, but really fascinating subject to think about, the length of time that the Earth has been around and the fact that we've only been here for a very, very short time. So anyway, I hope you've learned a lot in this lesson, and I hope you've learned a lot in all the lessons of the book. Some very interesting lessons. It's always great to look around the world around you and think about different things. You know, why are things that way? Why is it this way? What caused it? What's the result? And I hope you've learned a lot from the lessons in this book. Well, we'll see you later. Hope that you enjoy studying, of course, in the future, and I hope to see you again later on. Take care, everybody. Bye-bye.